I'm sure this looks like a familiar situation. You have a device that expects one sort of connector, but you have something that provides a different connector. Because of the mismatch, you can't make the connection. So, you'll need an adapter to, in effect, turn the different connector into one your device expects. Adapters are frequently used because different vendors will have different and evolving connectors for their devices. For example, a common connector for a peripheral device like a keyboard was once PS2, but computers in the mid-1990s started to only support USB ports. So people who had the older PS2 keyboards needed an adapter to use them with the new computers. This adapter converted a computer's USB port into a connector that the old keyboards could plug into. Software systems also face the same compatibility issue. Instead of having physical connectors, systems will have incompatible software interfaces. That is to say, the output of one system may not conform to the expected input of another system. You'll find that this is a recurring problem when your pre-existing system needs to incorporate third-party libraries or needs to connect to other systems. The adapter design pattern will help facilitate communication between two existing systems by providing a compatible interface. This design pattern is composed of several parts. Let's take a look at what they are. The client class will be part of your system that wants to use a third-party library or external system. The adaptee is, say, a class in the third-party library or external system to be used. The adapter class sits in between the client and the adaptee. It will implement a target interface, which is the interface that the client will use. The adapter conforms to what the client is expecting to see. The client sends a request to the adapter using the target interface. The adapter will then translate the request into a message that the adaptee will understand. Once the translation is finished, it will send the translated request to the adaptee. Now let's take a look at how we can implement the adapter design pattern in a specific example. In this example, we have a pre-existing web client that we want to use to talk to another web service. Our web client expects to send any object in a request, but the service only supports a JSON object. We need to use an adapter to convert our object request into a JSON object. Step 1. Design the target interface. You create the target interface that your adapter class will be implementing for your client class to use. Step 2. Implement the target interface with the adapter class. Your adapter provides the methods that will take the client class's object and convert it into a JSON object. This means that the adapter can convert any instance of a class that the client can create and send that in a request. The adapter class also handles transferring the translated request to the adaptee. The client class only needs to know about the target interface of the adapter. Step 3. Send the request from the client to the adapter using the target interface. The web client is responsible for doing some work to create your message for you. In your main program, you need to instantiate the web adapter, the web service, and the web client. The web client deals with the adapter through the web requester interface to send a request. Notice how your web client doesn't need to know anything about the web service, like its need for JSON objects. The adaptee is hidden from the client by the wrapping adapter class. So if two interfaces are incompatible, why don't we change one, or even both so that they're able to talk to each other? Well, if you've noticed in our example, we don't show the implementation of the web service class. This is because it's meant to represent a third-party library or external system that we may not have direct access to. If we did have direct access to those libraries or systems, an update by the vendors may make our changes inconsequential, or our changes may actually break those libraries or systems. Then why don't we just change our system's interface? Well, that might work, but what if a subsystem is using it? Changing assumptions like this can inadvertently break another part of our system. Remember that an adapter is meant to wrap the adaptee and expose a target interface to the client, indirectly change the adaptee's interface into one that the client is expecting by implementing a target interface, indirectly translate the client's request into one the adaptee is expecting, and reuse an existing adaptee with an incompatible interface. It isn't always practical to rewrite large chunks of your system in order to properly interface with new third-party libraries or external systems. Just because an interface doesn't conform to what your system is expecting doesn't mean that your system has to change. The adapter design pattern is a technique that helps bridge the gap between two incompatible interfaces. This will let you continue to use your existing systems and integrate external sources into them.